You have funny faces, Natalie. Okay, let's see. Example 2. That was the beginning of the video. How do you like that? Write an equation. This video is going to get all these hits because I want to hear the beginning of it. All right. Write an equation of a line that passes through these two right here. Now, the easiest equation to use, the easiest form to use is slope-intercept form in order to write an equation. No. Point-slope form, because all you need is a point and a slope. Do we have a point? Yes, Mr. Patey. In fact, we have 2 points. And so this is what you do. You have to find the slope. We don't have the slope. How do we find the slope? Well, one way to find the slope is you can graph those 2 points. So we have -3, -4 is right there. And you have 1, 1 is right there. Boom. Dang. Boom. That was way better. Now to count the slope, we must count the rise, which is 5. And then we have to count the run, which is 4. See? 1, 2, 3, 4, 5. And then 1, 2, 3, 4. Okay, so what is my slope? What's my slope equal, students?
5/4.
M equals 5/4. Now, there is another way to find it. You don't have to graph every single time, because if you graph every single time, that'd be annoying, right? It would be annoying. So how would you count the rise? Okay, well, this number right here is -4, and this number right here is 1. Now, when I say this number, I'm talking about the y's. How do you find the distance between 2 numbers?
Don't you do like x2 minus
x1.
Oh, guys, don't give me a formula. That's obnoxious. You subtract them. If I subtract -4 and 1, will I get the distance?
It ends up being a formula anyways.
But some people only remember it because of the formula. Now, okay, let's talk about the formula for a second. You guys know the formula. The formula is, what is it? X2 minus, no. Y2 minus Y1 over X2 minus X1. Now, can it also be Y1 minus Y2 over X2 minus, no, X1 minus X2? Can it be that? What about this? Can I write like this? Can I write Y1 minus Y2 over X2 minus X1? One of these is wrong.
Oh, that one.
This one. Can't do that. They have to be the same points on top of each other. Okay? And I don't like the formula. Why? Because some people think that only this is the right answer. That's not true. You can do this one also. It just matters the order that you subtract them in. So if I was trying to find the slope of these 2 points algebraically, or the slope of the line that contains those 2 points, I would say -4 minus 1. I just subtract the 2 y's. I subtract the y's right here. How do I remember the y's go on top? Well, Mr. Patey, that's the rise. X's do not rise. Y's rise. Okay? And then on the bottom, I'm going to go -3 minus 1. And you have to do the -3 first. That's why the y2 and the x2 are on top of each other, or the y1 and the x1 are on top of each other. And we subtract the 1, and then boom, we get our slope. Look, what does -4 minus 1 equal? -5. On the bottom, I get -4, which equals 5/4, because a negative divided by negative is a positive. So there's our slope. Now the neat part is this. Now this is neat. I like this stuff. Here's your slope-intercept form, or point-slope form. Y minus y1. Let's see. Let me write it up here for you guys, because some of you guys might have forgot. Y minus y1 equals m times x minus x1. Okay, so there's your formula. The y1 and the x1, that's the point you plug in. And so let's pick this first one right here. That would be minus -4, but we wouldn't write -4. What would we write? We'd write +4, and that would equal 5/4 x plus 3, because it says -3. Now this is point-slope form, and that's correct. But can you pick the other point? Absolutely. Y minus 1 equals 5/4 x minus 1, because that's the other x. So we have 2 different solutions if you leave it in point-slope form. Can I change this into the other forms? Absolutely. Here we go. All you got to do is solve for y. Now this one looks a lot prettier, so I'm going to do that one. Let's solve for y on that one. That says y minus 1 equals 5/4 x minus 5/4. I distributed that fraction right there. That's one way to do it. There's no other ways to do it, but that's the way I'm choosing to do it. And then I add 1 to both sides, but I don't want to add 1 over here. I want to add 4 over 4. That's the same as 1. You guys know why I want to do that? Because I want to find common denominators. Alright, so peace out 1. Then we have y equals 5 over 4x. And then what is negative 5 plus positive 4?
Negative 1.
Yeah, negative 5 plus positive 4 is negative 1. So we have minus 1/4. This is slope-intercept form. Now, how would we make that general form? Well, we can't have fractions in general form, so you guys know how to get rid of the fractions? Yes?
Multiply everything by 12.
By 12. How come you pick 12?
You told us that any fraction can be gotten rid of if you use 12.
No, not any fraction. No. That's not true. What the truth is if you multiply everything by the common denominator. Now, the problem that we were looking at, that you're talking about, probably had a common denominator of 12, which is why we were able to eliminate all the fractions using 12. Here, our common denominator is what? 4. So if you multiply everything by 4, then you can get 4y equals 5x minus 1. So I need to clarify. My students were telling me that I did not say we're trying to make it into standard form. So we're trying to make this dude into standard form. And then subtract 4y from both sides. So we have all the terms on the same side. So I have 0, 5x minus 4y minus 1. This is general form, but how do we make it a standard form that we learned? Yeah? Get that 1 to the other side. So we add 1 to both sides. We get 1 equals 5x minus 4y. So there we have 3 different ways to write this equation that it's talking about. Here's point-slope form, here's slope-intercept form, and then we have standard form down here. Now, last thing I gotta show you. I know I show you guys lots of stuff. Now this is the same equation. It's talking about the same equation. It says it's talking about an equation that contains negative 3, negative 4, and 1, 1. But this time it says write an equation that's parallel to it and write an equation that's perpendicular to it. Now, in order to do this, you have to know the slope. So if we draw what we had before, there you have it. That's the equation that we had before. What was the slope for that one? M equals 5 over 4. Now, if you want a parallel line, you guys know what parallel means? They don't intersect. Okay? Now, what controls the tilt of the line? When I say tilt, I mean slope also. Like what controls it to make it go like that, or what controls it to make it go down like that? That's the slope. So, we need to have the same slope for a parallel line. If we want a parallel line, one line that does not cross the other line, then our, oops, it's my parallel sign. Our parallel slope has to be the same, 5 over 4. Now let's pretend this line crosses, what number is that? That's a 6, looks like. 1, 2, 3, 4, 5. Oh, it's a 5. Okay, so let's say it crosses 5. You can easily write an equation now. Y equals 5 over 4 x plus 5. Boom. I wrote my equation. Now, how did I pick 5? Why did I pick 5?
Because it has to be different y-intercept.
Yes, it needs to have a different y-intercept than this one to be a separate line. Now, sometimes the problems give you a point. It says it has to pass through negative 2, 1. And then you would just use this point and find your new y-intercept. Or just use this point and use point-slope form. What does it say? Now, for perpendicular, the line has to pass through it perfectly to form a right angle. The perpendicular slope, do you guys remember this one?
It has to be inverse opposite.
It's the opposite. So because it was positive, now it's negative for the perpendicular one. And then you have to take the reciprocal. So 4 over 5, and that's what you got. So let's write the equation for it. Y equals negative 4 over 5, x plus, 3. And I can pick this because it didn't give me an exact point. This problem didn't give me an exact point to make an equation 4.